Hello, and welcome back to our ongoing series of Rusteroids, recreating an Asteroids clone using Rust. Today, we will add in our first asteroid, and do this using the specs dispatcher to encapsulate the movement code for the asteroid in a single isolated location. As usual, let's check that we have the code from the previous tutorial working. It should be the spaceship, movable with W, A and D, and should have momentum when we stop pressing the W key. If your code doesn't have this, you can simply type git checkout tutorial 7 from the GitHub repository to get the code at this point. The first thing we need to do is change how we render the rotation of each object, as this will need to be independent of the direction of travel for the asteroid. In order to make this work, we will change the update function inside game.rs. We will need to add in a mutable variable referencing the write storage for the renderable components. Then we will need to create a reference to these components in the join, part of the for clause. Scrolling down to the bottom of the function, we now need to set the renderable rotation to be the same as the player character. First, we add in a comment to make it clearer. Then, we set the actual value of the renderable. Then we go back to main.rs and the render function, and we set the rotation of the object being drawn to be the renderable.rotation instead of the pos.rotation. Next, we go back to the components.rs file and scroll to the bottom. We can simply take a copy of the player struct and change the name to Asteroid, and then we will update the attributes to be speed of type F64 and another of rot speed, also of type F64. Then we will go back to our main.rs file and scroll down to the part where we register the component types with the ECS, or Entity Component System, and we will register our new asteroid component. After this, we'll scroll up and add in the image of an asteroid into the texture manager by simply copying and pasting the old one and changing the value of image/asteroid. The image can be found in the repository and will need to be placed in the image folder if you don't have it already. You can see that we have our asteroid image in that folder ready for us. Going back to the game.rs file, we can now add in the asteroid as a component in the Entity Component System. As before, we will call ecs.createEntity, and then filling in the with call with createComponentsPosition, setting the values to 400 and 235, and setting the rotation to be 45. Then we will add a component of type renderable. We can copy the details from the player above. Remember to change the texture to asteroid.png and make the output width and height to be 50. Finally, we will add an asteroid component, setting the speed to be 2.5 and the rotation speed to be 0.5, because we want it to constantly spin. Lastly, we call build on that to finish making the component. At this point, it is probably worth scaling down the size of the player character so that we don't dwarf the asteroid, and to provide more room for other asteroids and objects. We will scale this down to 50 by 50. We will use cargo run to check the code at this point. And we can see we now have an asteroid being drawn to the screen, but it's not moving. Even as the player moves around it, it won't ever move, because we need to add in the event dispatcher first. Closing that down, we're going to need to add a dispatcher, but before we do that, we will create the movement object for the dispatcher to call. We will create a new file called asteroid.rs to hold this. We will need to import the parts of the specs library that we need. These are system data, write storage, and join. Then we will create an empty struct called asteroid mover. After that, we will use create components to save us typing the create part every time. Now we're going to implement system for asteroid mover, and that will have a lifetime of A. Inside this implementation, we create a type called system data, and in here we create a tuple of write storages with a matching lifetime of A, and we do this for position, renderable, and asteroid. Then we create the run function, and this is the body of the dispatched event that will run every time the dispatcher is called. It takes an argument of self, which is mutable, and then we reference the internal type of system data, calling it data. Then, as with our update function, we create a for loop, looping through each of the joined components. But because they're in a tuple, internally we reference these as data.0, data.1, and data.2. Data.to doesn't need to be mutable because we're only reading from each asteroid object. Finally, we join those so that we get each one in turn. The next part will seem very familiar as it's broadly the same as the update function for the player. We first grab a reference to the radian rotation. Then the x position is the asteroid's speed multiplied by the sine of the angle in radians. And the y position is the same but with cos, remembering we need to subtract it because the axis is inverted on a screen. Next up, we will make the asteroid bounce, and first we need to get the half width and half height of the asteroid, because the position of the asteroid is the center of the image, meaning if we don't account for this, it will overhang the screen by half of the image width, which we don't want. We get these values by dividing the output width by 2 and storing the result as U32. Now we have those, we need to check if the position.x is greater than the screen width minus the half width of the asteroid, or if the position.x is less than the half width, and remembering the .into functions to do the conversions for us. If either of these is the case, we will subtract the current rotation from 360 in order to get the new rotation angle. The other condition we need to worry about, of course, is if the position in the y-axis is greater than the height minus the half height, or if the position is less than half height. Unfortunately, the maths for this isn't quite so convenient, so we'll need to check two further conditions. If the rotation is greater than 180, then the rotation is 540 minus the current rotation, and if the rotation is less than 180, the new rotation is 180 minus the rotation. We can just catch all eventualities here, so we just put else. We also need to make sure that all values are floats by adding a 0 to the end of the ones we missed. And we outdent to make sure the brackets match. We need to increment the renderable rotation by the rotation speed of the asteroid. This will keep our asteroid spinning constantly. Then we will add in boundary checks to make sure the rotation stays within the bounds of 0 to 360 degrees. And the movement for our asteroid is now completed. We now need to add it to the dispatcher. Back in main.rs, we need to add a reference to the new module we've just created, pubmod asteroid. We also need to pull in the dispatcher builder from the specs library. We will then scroll down to just underneath where we register the types with the ECS and create a new variable called dispatcher. It will be mutable, and then call the dispatcher builder constructor. On the next line, we add a with clause, and the type is asteroid mover, the type we just created. Give it a name of asteroid mover and pass in an empty list reference for the final argument. And finally call build to finalize the creation of the dispatcher. Lastly, we need to scroll down to our call to game update and add in a call to the dispatcher under that by calling dispatcher.dispatch and passing in a reference to the game state ECS. And again, we will try cargo run. And we have an error in asteroid.rs. We add in the missing semicolon. Doing another cargo run, we can see the asteroid is moving on its own and rotating slightly as it goes. We can move the character and see the asteroid bouncing around. In the next session, we will add in collision detection to add some danger for the player. But for now, I wish you a great day and hope to see you again soon. Bye for now.